Hello guys. So we are taking the topic solution of trigonometric inverse equations. So right now we will solve these equations and we have a unknown term x. So we will solve this equation using left hand side and right hand side both and complete equation, and after solving we will get the value of x. So how to solve the questions of trigonometric inverse equations? So right now we are taking the question tan inverse 2x plus tan inverse 3x equals to pi by 4. So uh, this is the summation of two tan inverse, and according to uh, theorems of inverse, we have a formula tan inverse x plus tan inverse y equals to tan inverse x plus y over 1 minus xy. Now we will use this, and these are unknown terms, non-numeric terms. So when we apply, then we get tan inverse summation of these two. It is just like x and y, or you can say a and b. So in numerator we will take the sum, and in denominator we will write 1 minus the product of these two. So we have tan inverse 2x plus 3x, that becomes 5x, and 1 minus the product of these two, we get 6x square. And on right hand side we have pi by 4. So tan inverse of this, when tan inverse comes on this side, that becomes 10 pi by 4. So it will be 1. 5x over 1 minus 6x square equals to 1. So on placing this, 5x equals to 1 minus 6x square. So on taking these on left hand side, we get 6x square plus 5x minus 1 equals to 0. So right now this equation convert into this form, and this is a quadratic equation, and we will factorize it. So on factorization, so it is 6x square, and the factor of this is 6 and 1. 6x minus x is minus 1. So we take 6x as common, 6x, and this is x plus 1, and this is minus 1 x plus 1. So on factorization we get 6x minus 1 into x plus 1. So we will get the two values, x equals to 1 by 6 positive and x equals to minus 1. Right now we have two answers, but we will pick that answer which satisfy the equation. So when x is minus 1, so we put this on left hand side, we get tan inverse, and this is 2 into minus 1 is minus 2, and when we put this in tan inverse 3, so it is tan inverse minus 3. So this is the, on left hand side we can check it, this is negative. So left hand side is right now negative, but on right hand side we have a positive pi by 4. So this can't be equal. So this answer is not accepted, or you can say it is rejected. So the result which will be accepted, that is x equals to 1 by 6. When we put this, it is tan inverse 2 by 6 is 1 by 3, and when we put this on this side we get tan inverse half. On applying this formula we get tan inverse 1 by 3 plus 1 by 2 and 1 minus 1 by 3 and 1 by 2. So we get tan inverse, on taking LCM, 6, and we get 5 by 6, and in denominator also 1 minus 1 by 6 is 5 by 6. So these cancelled out, we get 1. Tan inverse 1 is pi by 4. So this is our answer. This way we can say 1 by 6 is the correct answer. So on solving this equation, we get x equals to 1 by 6, and x equals to minus 1 is not accepted because this can't satisfy the condition. Now next question, again this is the tan inverse unknown terms, that is x. So we will solve this equation, solve for x. So now we again collect the value of x. So we have right now, according to this question, tan inverse x plus 1 plus tan inverse x minus 1 equals to tan inverse 8 by 31. Right now we will use the complete equation. This is not the proving question on the left hand side to right hand side. Right now we use the entire equation and we will collect the value of x. So according to this, we have on left hand side we have 2 tan inverse, and according to tan inverse theorem, when we sum the 2 tan inverse, and its formula is tan inverse sum of x plus y and 1 minus their product. So right now it is just like x, this is just like y. On applying this formula, we get tan inverse the sum of these over 1 minus product of these. So it is x plus 1 plus x minus 1 divided by 1 minus the product of these two, x plus 1 into x minus 1, equals to tan inverse 8 by 31. And right now when we expand this, we get x plus 1 and x minus 1. Right now 1 will be cancelled out and we get 2x. And in this 1 minus, there is a square minus b square formula, so 1 minus x square minus 1, so it becomes 1 minus x square plus 1. So now the next step, that becomes tan inverse 2x, and this is 1 plus 1 is 2 minus x square, equals to tan inverse 8 by 31. So right now both side tan inverse, so it will be neutralized. So it is 2x over 2 minus x square equals to 8 over 31. Right now we convert this expression into a quadratic equation. So we will cross multiply this, we get 62x, and this is 16 minus 8x square, and on taking left hand side we get 4x square plus 31 minus 8. We will divide this equation by 2. So it is this equation. Right now factorize this. So on factorization we get 4x square plus 32x minus 31 and this. So 32 and 1 is the factors. So on taking common as 4x, so x plus 8, there is minus 1 will be common, x plus 8. So we have these two factors, x 4x minus 1 into x plus 8 equals to 0. According to this equation, we will obtain these two answers. One possibility is x 1 by 4 and other is x equals to minus 8. So right now we will check these two values on the given equation, and we will check which value of x will satisfy this equation, and that will be accepted. So right now we are taking x equals to 1 by 4. So on putting this value in this, so x is 1 by 4, so it is 1 by 4 plus 1, that becomes 5 by 4. And in case of x minus 1, when we put 1 by 4, 1 by 4 minus 1 is minus 3 by 4. So right now we will place this tan inverse 5 by 4 minus 3 by 4, and on solving this we get tan inverse 8 by 31, which is our required result. So we can say this value satisfy the given equation. Right now we will check x equals to minus 8. So on putting this value in this equation, so minus 8 plus 1 is minus 7, and minus 8 minus 1 is minus 9. So on left hand side we have the negative tan inverse, so result will be negative, but the in the equation right hand side is positive, so it can't be possible. This is not satisfied, so we can say easily answer is x equals to, and this is rejected. Now next question, tan inverse of x minus 1 over x minus 2 plus tan inverse of x plus 1 over x plus 2, the same thing, but these negative becomes positive, equals to pi by 4. So tan inverse, we have the summation of two tan inverse, so we will again use the formula tan inverse x plus y over 1 minus xy. So the sum of these two divided by 1 minus the product of these, so we get equals to pi by 4. It means on taking LCM we get x minus 1 into x plus 2 and x plus 1 into x minus 2, and the LCM is x minus 2 and x plus 2. Again on denominator the same LCM, so we can cancel out the LCM and we get x minus 2 into x plus 2 minus this one. So on multiplying this we get this, and this factor is x square minus 2x plus x minus 2, and this is a square minus b square, so we get x square minus 4, and there is x square minus 1. On solving, on opening the bracket, we get minus x square plus 1, and there is 2x and this is minus 2x, so this will be cancelled out. This is minus x and this is plus x, so finally we get x square plus x square, that is 2x square, minus 2 and minus 2 is minus 4, and in denominator we have minus 3, and equals to, when tan inverse comes here, or you can say 10 pi by 4, that's value is 1, so it is 1. So 2x square minus 4 over minus 3 equals to 1, means 2x square minus 4 equals to minus 3, and 2x square equals to, when it comes here, minus 3 plus 4, you get 1, means x square is 1 by 2. So x is plus 1 over root 2 and minus 1 over root 2. So these are the values of x. This is the answer. Now the next question, solve tan inverse 1 minus x over 1 plus x equals to half tan inverse x, and we follow this condition, x, the value of x should be positive or greater than 0. So this is tan inverse 1 minus x over x plus 1, and we take 1 with multiplication with x, and this is half tan inverse x. So it is tan inverse 1 minus tan inverse x. We can use the theorem, if tan inverse x minus y over 1 plus xy, so we can also write tan inverse x minus tan inverse y. So using this theorem we can convert this tan inverse 1 minus tan inverse x, and this is half tan inverse x. When tan inverse x comes on this side, then the half tan inverse x plus tan inverse x is 3 by 2 tan inverse x, and on left hand side it is tan inverse 1. So tan inverse 1 is tan inverse 10 pi by 4. So tan inverse 1 equals to 3 by 2 tan inverse x. So right now this is 3 by 2 tan inverse x equals to tan inverse, and we substitute the value of 1 as 10 pi by 4. So 10 by 4 equals to 1. We put it here and we get pi by 4. It means 3 by 2 tan inverse x equals to pi by 4. So tan inverse x equals to 2 by 3 pi by 4. Cancel out this and we get the pi by 6. So tan inverse x equals to pi by 6. It means x equals to 10 pi by 6. And it is clear the value of 10, 30 or 10 pi by 6 is 1 over root 3. So we put it here. So the value of x is 1 over root 3. So it is our answer. Now next question. Solve this equation. It is twice of tan inverse cos x equals to tan inverse of 2 cosec x. Right now 2 is outside tan inverse, but in right hand side 2 is as a value 2 into cosec x. So the formula of 2 tan inverse x is tan inverse of 2x divided by 1 minus x square. We use this theorem or this formula at this place. So right now in place of x we have cos x. So it is twice of x divided by 1 minus x square. Same way we will place 2 cos x. It is twice of this minus 1 over square of this. So it is cos square x. Right now this is tan inverse 2 cosec x. And this is the left hand side is tan inverse of this and right hand side is tan inverse of this. So it means these are equal. 2 cos x over sin square x equals to 2 cosec x. Now convert the cosec x as 1 over sin x. And sin square x comes on this side, so we cancel out this, we get sin x. It means cos x equals to sin x. That means sin x over cos x equals to 1, and sin x over cos x is tan x. Tan x is 1, and the value of 1 in terms of tan is 10 pi by 4. So we can equate these. It means x equals to pi by 4. This is the answer. So these type questions are given for solving x, and we will use these theorems, inverse theorems, to simplify this. These are very easy and interesting questions. Anyone can solve these after few practice of these formulas or theorems. It is very easy. Thanks.